Welcome Year 9 to Circuits Construction. So this is an application on a laptop, but if you search the App Store for some free apps, I'm sure you can find some very good, simple applications that allows you to build series and parallel circuits. So I'm going to start by building a simple series circuit. So just from remembering in class, we have our battery, we must have our connecting wires, and that just allows the electrons, which is current, to travel through the circuit. So I'm just going to set up the circuit like so. So based on our diagrams in class, we've always had our battery at the top and center of the diagram. So at the moment we have a pictorial representation, but I want you to try and imagine the symbol for a battery and the symbol for the wires just being straight lines. So I'm just going to represent a single globe for you. Single light globe in series. Okay, so we can visually see that the light globe is bright. We can see these dots moving around the circuit through the globe and back out towards the battery. Those dots are representing electrons, and that is just saying the current is moving. So the current is existing, so it's moving. And the current itself, as we know, is just electrons, which are those negatively charged particles moving through a light globe. As it moves through the globe, there is a very special metal, usually tungsten, that lights up, and that energy is lost in the form of light, which is very useful for us. So I'm just going to try and disconnect those now, and I will just attempt to add an extra globe here, and I want you to notice what happens. This is still a series circuit, the way we're constructing it. I want you to notice what happens when we add an extra globe in series. Okay, so we can safely assume that the current is still working, the light globes are still on, but you should be able to notice that they are not as bright. So in a series circuit, the more globes that we add, and this is very important, the more globes that we add, the more that voltage is shared between them. So each globe is getting that little bit less voltage each. So that's our series circuit. So I'm going to stop that again now. I'm going to remove this globe, and I'm going to set it up as a parallel circuit. So our parallel is when it looks quite different. It almost looks like a bit of a ladder. So here we have a single globe with the brightness before. So this is still, again, our simple series circuit. I'm now going to connect the wires together to make a parallel circuit. So it takes that ladder shape that we've been learning about. And I want you to notice, as I unclick here, I want you to notice the brightness of that first globe and compare it to the brightness of the second globe. 3, 2, 1. So hopefully you were able to notice there was no difference in brightness. By adding a second globe in parallel, they are no longer sharing that same voltage. Every single globe, so first globe and second globe, is receiving 100% of whatever voltage we have in this battery. I want you to think of this type of setup as the setup you would have at your home, or especially in the classroom where we have multiple light switches for the different sections of lights. So they're on their own switch and they have their own section. This is very important in different applications that we're going to explore later.